Hello everyone, in the previous video, I introduced the three forecasting techniques, and in this video, I will introduce some approaches to assess how the forecasting model perform the forecasting job. So one thing to measure whether the forecasting model has a really good or really bad performance is this so-called forecast error. So the absolute forecast errors we can represent it as the percentage of realized value. So the absolute forecast error, this is a definition. So it's the forecast value minus the realized value, and we take the absolute value of it. And then we divide the realized value so we can represent the forecast errors as a percentage of realized value. So here's how we calculate the absolute forecast errors. For British pound, the forecasted value is 1.35, but the realized value is 1.5. So then the absolute forecast error should be, as the formula, 10%. And for Mexican peso, the forecasted value is 0.12 and the realized value is 0.1. So the absolute forecast value is 20%. So then we found that the forecast error for Mexican peso actually is larger. If we do not represent it as a percentage of realized value, then the absolute forecast value for British pound is $0.15. This is absolute value. And for Mexican peso is 0.02. So in this case, if we just look at the absolute value, we may think that Mexican peso actually has a better performance. But once we represent it in a percentage of realized value, we will realize that this smaller absolute value of Mexican peso is because the exchange rate for Mexican value itself is smaller. So, that this just try to illustrate why we represent this absolute forecast errors as a percentage of realized value is so important. And also, we should know that over a long time horizons, the forecast error should be larger because it's really harder. It's harder to forecast the long-term movement. But if we only forecast the next 1 or 2 days, then the forecast error should be smaller. It's relatively easy to make a very accurate forecast over the next couple of days. And sometimes you should know the forecast error for a given foreign currency will change over time. In some period when the economic condition is relatively stable and the political environment is stable, the currency will have a relatively smaller volatility, the forecast error will be smaller. If the economic condition deteriorates and the political environment is really harsh, then the foreign currency will have a very high volatility and the forecast errors will become larger. And also, we will find that the currency with relatively high volatilities like Australian dollar, New Zealand dollar, those currencies will have relatively high volatility, so it has a relatively higher forecast error. For Chinese yuan and Singapore dollars, those are currencies with relatively smaller volatility. The forecast error will be smaller. And how to compare the forecast errors among forecast models. So here is one example. experts use a fundamental forecasting method to forecast the exchange rate of Polish currency. So they have two methods. The first model, this is a predicted value for first model. This is a predicted value for second model. And the realized value, those is the real numbers. So you can observe from the market. So what the model will do is like at t equal to 0, this company use model 1 and 2 to do the forecasting. They get those forecasted value for t equal to 1. So next period, those two values, the model generated those two models generated different forecast values, and then we can predict the period 2's percentage change, the exchange rate. It will generate, each model will generate one value, forecasted value, and then at t equal to 1, at the end of t equal to 1, we will observe from the market that what's the price of the loyalty. This is Polish currency's value on the market, from the market, and at the end of period 2, at the end of period 2, we will observe from the market. This Polish currency's value is the true value from the market is $0.14 per unit. Then we can compare the realized one with the forecasted one to evaluate which model has better performance. So we can find out the absolute forecast error. We do not represent in the percentage because we just compare two models for the single currency. So the realized value for both models are exactly the same. So we found the absolute forecast error using model 1 is for the period 1 is $2.2 minus $0.16, take the absolute value. And we found out the average forecasted error is $0.04. And then for model 2, the absolute forecast error, the average is 0.7. So we know model 1 has a smaller forecast error, it has better performance. Or we can use regression model for forecast bias. So we can use the realized value, which is ST. This is the realized value as Y, and regress it on the forecasted value. So this is the T minus 1. This T minus 1 means when the forecasted was done. And the forecasted value is for period T. So basically, this forecast T minus 1 means we use this model at T equal to T minus 1 to predict the future movement at time T. And this mu T again is an error term, and we assume that the average mu T equals to 0. And A is the intercept, is a constant. And A1 is a regression coefficient. So if the forecast is unbiased, the intercept should be equal to 0, because ST should exactly equals to the forecast value. So A0 should equal to 0, and the regression coefficient A1 should equal to 1. If A1 is less than 1, which means this is an the model overestimated the realized value. So if forecasted value is 1, then realized value should be, if the coefficient is 0.8, which is less than 1, the realized value is 0.8. If the forecasted value is 1.2, then the realized value is 0.96. if the forecast value is 2, then the realized value is 1.6. So ST is overestimated by the model. If A1 is greater than 1, for example, the A1 is 1.3, then which means ST is always greater than forecasted exchange rate. Then we say this model underestimated ST. So if forecast value is 1, the realized value is 1.3. If the forecast value is 1.2, then realized value is 1.56. And if forecast value is 2, the realized value is 2.6. So the realized value is always higher than the forecast value. So we say the realized value is underestimated. And we can also use a graph to visualize the forecast bias. Multinational corporations, they can just plot it. So if the forecast error measured as the forecast value minus the realized value. So if the negative error, which means the forecast value is less than the realized value. Which means the realized value is underestimated. And if it's a positive error, means the forecast value is greater than the realized value. In this case, which means the model overestimated the realized value. So here is what we seen in previous example, and we can plot. Those are predicted one, and this column is the realized value, and then we can plot this. So for first period, the predicted value is 0.2. And then the realized value is 0.16. So we found that the predicted value is greater than realized value. And the perfect forecast line is in the middle. So if the dot right lines on this line, which means the forecast value equals to realized value. So for period 1, we know this is overestimating. And for period 6, the predicted one is 0.22. And the realized value is 0.26. So which means that the predicted value is less than the realized value. So which means 0.6 in period 6, the model underestimate the realized value. So basically means like if we use the horizontal axis as predicted value and the vertical axis as realized value, then we can draw a middle line here. We can draw a vertical line, draw a line here in the right in the middle. So the degree of here is 45 degrees, and when the dot is under this, it's under this line, below this line, which means the model overestimating the predicted value. And when the dot is above this line, which means the model actually underestimated the actual movement. I think for this video, I will just stop at here. In the next video, I will wrap up chapter 9 and do some practice. Thank you for watching. Bye.